Today we're working on mid-segment of a triangle, and this has a very intuitive feel to it. You're going to make a lot of sense of it very quickly, and it's pretty great. So here's the idea that the mid-segment of a triangle is the segment that connects the midpoints of the two sides. Okay, so if you have this for any particular side, if you like the side down here in blue, if you pick the midpoints of the two other sides and connected them, you would get these certain features. Okay, um, you would get the fact that that mid-segment connecting the two midpoints is parallel to the opposite side there, and also it cuts it into two equal parts. Makes sense because that's the what do you call midpoint. So this you get this segment and this segment being equal. That's obviously what a midpoint means. But you get something else that's really cool, which is that the length of this mid-segment is exactly half of the length of that parallel side. Yeah? Pretty good, right? So let me read it here for you. If a segment joins the midpoints of two sides of a triangle, then the segment is parallel to the third side and half as long. Neat. We're going to use that. Let's apply it to some problems. By the way, this is an explanation of showing that it works, but I'm not going to go into it in great detail. I'll just tell you the main points of it. Is that if you took some triangle and you took the endpoints of this one side here, that you were taking the midpoints of the other two sides to get the midsegment, you would take whatever this point is and this point, and you would calculate the midpoint of it, okay? And you would do this, whatever this point is and this point is, using the midpoint formula, calculate the midpoints. So you'd know exactly that you were at the midpoints. Well, using those two ends, you could calculate the slope of that line. Using these two ends, you could calculate the slope of that side, and you would see that you get the same slope, okay? Also, using the distance formula with these 2 points, you could find the length of that side, and doing the distance formula for these 2 points, you would find the length of the mid-segment, and you would find that it's exactly half, okay? So you can look at this in more detail, but that's what they're doing there to show that this works. All right, now let's identify the parallel segments. What are 3 pairs of parallel segments in this triangle, triangle DEF? Well, as you can see, they've uh, put the midpoints of each side and labeled them R, S, and T respectively. And so what are parallel sides? So if we look at that, we can say, well, we've got RS parallel to DEF, right? That opposite side that's not uh, part of this mid segment is made by two endpoints that are midpoints of that side and that side. This other side is what it's parallel to. So side mid segment RS is parallel to DF right there. We've also got segment RT is parallel to segment EF. It's right there. They've reversed the letters, but that's fine. And we've got here segment ST is parallel to side ED. Yep, that's how you do it. It's pretty, I think, obvious to you there. Now, oh, and by the way, they just say here, how do you identify a mid-segment? You look for indications that the endpoints of the segment are the midpoints of a side. And you know that this particular point R is the midpoint of DE because it splits it into two congruent segments. Okay? So here you're going to have to draw this out. In triangle XYZ, A is the midpoint of XY, B is the midpoint of YZ, and C is the midpoint of ZX. What are the 3 pairs of parallel segments? You'll need to draw that triangle out and plot the midpoints and label them as well to solve this, okay? And you've also got this problem here. What is the measure of angle BUO in the figure at the right, and explain. Work on that for a second. So here you can see that I have drawn out this triangle XYZ. Here's XYZ, and A is the midpoint of XY right there. B is the midpoint of YZ, and C is the midpoint of ZX. And I could put those marks like they did up here to show that that is the midpoint, but since they're telling us it is, that if you see C there, you know that it's the midpoint. So I don't need to mark that. What are the three pairs of parallel segments? Well, here I've written them out. You can see that mid-segment AC is going to be parallel to that side, YZ. AC is parallel to segment YZ. AB right here is going to be parallel to this side, XZ. So segment AB is parallel to segment XZ. And BC right here is going to be parallel to this side right here, XY rather. All right, you could call it YX or XY. There you go. Hopefully you should see that. Now, what is the measure of angle VUO? VUO is right here. Let me put it in a different color. This right here, angle VUO. And what is the measure of it in degrees? Well, let's see what we know. We know that this side is parallel to this side because that's what mid-segments do, is they run parallel to that opposite side there. And since they're parallel, corresponding angles when the two lines are parallel will be congruent. So if this is 65 and these two lines are parallel, this will be 65 as well. So we have as an answer that it is 65 degrees. In this problem, they are asking for this triangle QRS, where we have these lengths. This side QS is 50, this side RS is 40, and this mid-segment here, BT, is 30. Okay. What are the lengths of these other segments? TU, UB, and QR. Okay. Well, it's a fun fact, and we know this actually in our mid-segment theorem. There's several parts to it, and which part do we want to use? It says you're asked to find the length, so we're going to use a relationship that refers to the lengths of the midsegment and the third side, meaning we always have the midsegment half the length of the opposite side, okay? Or if we knew the midsegment, like in this case, we could double it for that side. So what do we get for the relationships? This is what we get. TU right here is going to be half of whatever this opposite side is because it's the midsegment, so it's going to be 20. UB right here is going to be half of that side of that triangle, or 25. And here, TB is 30. And so what do we know about QR? It's going to be twice that much. It's going to be 60. Very straightforward. Okay. What about here? What are the lengths that they are asking for in this particular got it problem? Give it a go. See how you do. So what do we know here? Let's take a look. They say that AD is 6, and that's the same length as this right here. So AD plus that same length here, for DC, it would be 6 plus 6, which is 12. So AC measures 12. Okay? And as it turns out, FE, or EF, is exactly half of that. Okay? Since it's exactly half of that, what's half of 12? It's 6. We know that. What else do we know? We know that if DE is 7.5, then each portion here is 7.5, making AB 15. Okay, and what about DC? Well, DC is this segment here that is equal in length to AD because they have the double segment marks, meaning that AD and DC are the same, and they're asking about DC. So if this one was 6, then this one will be 6 as well. There you go. All right, now a very cool feature of this idea in the real world is that you can use the mid-segment formula or mid-segment theorem, the idea of mid-segments, to measure distances that you might not be able to measure directly or would be difficult to do anyway. And here's the setup here. Okay, a geologist wants to determine the distance AB across a sinkhole. They've taken this sinkhole here and they've kind of made a diagram of it. Okay, and they want to measure that distance across, but obviously you can't just walk across and measure it. So, okay, choosing a point E outside the sinkhole, this geologist, she finds that the distance from A to E here, uh, and the distance E to B here, and then finds that mid segment by doing exactly half of that length, putting a point here, half of that length, and putting a point here. Okay, locates the midpoints of C and D, midpoint C and D of those sides, and then measures what is segment CD. Okay, so then the question is, what is the distance of this? Here it's 46 feet. Okay, and why do they do that? Because uh, that will be half of the length across the sinkhole. 46 will be half of this length because it's a mid segment. Okay, so what you do here is you say, if you were to calculate this, you would say since CD is the mid segment, CD is going to be exactly half of what AB is. And if you undo this 1/2 by multiplying both sides by 2, you find that AB is 92. You might not have even needed to do this formally because you know that you can just double it. Okay? Anyway, the distance across the sinkhole is 92 feet. So here's your got it problem. Give it a go. All right. So if CD is a bridge built over the lake and it's as labeled at the right here, what is the length of the bridge? Well, the bridge is going to be exactly half, since we see that this segment is 963 and this is 963, that must be the midpoint. And since these two have single segment marks, D must be the midpoint as well, which makes CD the mid segment. We needed to demonstrate first that this truly was the mid segment. Okay, but by saying that this portion is equal to that portion, that means D is the midpoint. That this portion is equal in length to that portion, C is the midpoint. Since we know that segment or side CD, or the length of the bridge, is going to be half of this. And if you do that math, you will find that the bridge is 1,320 feet in length. Neat. Okay, and that's the lesson. So these lesson check problems, I don't have the answers posted yet. I will post up a revised video with the answers embedded once I get access to the teacher edition again. I mean, I could solve these all out, but it's just easier to post it as a tight little screenshot from the teacher edition. So I'll wait for that. It's coming soon. Anyway, I hope you did well. Do your homework and see how you do. Ask me questions if you need to.